All right, welcome back. We're taking a look at the quantum mechanical model, day 2, and picking up right where we left off from day 1. So yesterday we took a look at the 3p. The second energy level is followed by the 3s and then the 3p. So just like we had the 2s and the 2p, we have the 3s and the 3p. So I think we finished up here with aluminum. There's our 3 2p orbitals. We filled those guys up. We entered the third energy level with the 3s, put the 2 electrons in that, and then we moved to the 3p. Aluminum had just 1 electron. We did show all of our empty orbitals, but just 1 electron. Electron configuration, again, 1s, the 2s, the 2p, the 3s, and then just 1 electron in that 3p. Sulfur, another element that has its outer electrons in the third energy level. It filled up the 1s and the 2s, moved to the 3s, the 2p, then the 3s. And after the 3s comes the 3p. Again, we went up arrow, up arrow, up arrow, came back with our down arrow, and this one ends in 3p4. 4 electrons in the 3p. All right, so hopefully you're starting to pick up the patterns here. This is the 3p in pink up here. We just did aluminum and sulfur. And next we move to the 4th energy level. So here's the first energy level, again, hydrogen and helium. The second energy level is lithium, beryllium. We jumped over to boron, carbon, nitrogen, oxygen, fluorine, and neon. For the third energy level, we started with sodium and worked our way through argon. And then once you're done with the third energy level, move to the 4th energy level. And we start, just like with every other energy level, we start with the s orbital, the 4s. Just like all other s orbitals, it is spherical in shape. It's just going to be a little bit larger. It's going to surround the 3s, which surrounds the 2s, which surrounds the 1s. In orbital notation, we'll take a look at calcium here. We fill up the 1s. That was the top energy level here. We move to the 2s. That's lithium and beryllium. The 2p is boron through neon. We fill that guy up. Move to the 3s, sodium and magnesium here. And then we go to the 3p. And again, calcium will have the entire 3p filled up. So there's all 6 of those electrons. Then we go to the 4s. And hey, any s orbital, doesn't matter if it's 4s or 5s or 6s, any s orbital has just 2 electrons. So there they are. There is the orbital notation for calcium. Again, taking a look at the electron configuration, it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. All right, so starting the 4th energy level, just like all the other energy levels, and then things change just a little bit. Just as soon as you get ready, recognizing the pattern. You'll see we now come, after calcium, we now come into this pink block, kind of in the middle here, starting with scandium, Sc. That is a whole new block. We've got S block, maybe you guys have recognized that. And we've got P block, we'll work with that a little bit. S block is 2 elements wide, because you can put 2 electrons into the s orbital. P block is 6 electrons, or 6 elements wide, because you can put 6 electrons into the p orbital. Well, now we've got what we call the d orbital. So after the 4s, our pattern changes. We're actually going to go back to the 3rd energy level. It doesn't seem to make a whole lot of sense. I'll talk about that a little bit more in just a second. But we go back to the 3rd energy level and open up what we call the 3d, which is right there. There's our 3d. The d orbital is kind of shaped like a double p orbital. I couldn't even try to draw it if I wanted to. So you see this is 1d orbital. Here's 1d orbital. Here's 1d orbital. Here's 1d orbital. And then there's the fun d orbital with the donut in the middle. It's everyone's favorite. Kind of a cool looking one. There are 5 different d orbitals. So we see those 5 right here. And kind of looking at that energy. Why did we go up to the 4th, open up the 4s? And then come back to the 3d? Well, looking at off-Bose energy levels. Again, we always have to fill the lowest energy level first. So we started with 1s, moved to 2s. From 2s we went to 2p. 2p is a little bit higher than 2s. Better jump up to 3s, then 3p, and then again comparing 3d with 4s. 4s is a little bit lower than 3d. So according to off-ball's energy levels, we're going to fill up the 4s first. Then we move to the 3d. So that's why we opened up the fourth energy level before coming back to the third energy level. If you're looking at this like, man, I can't memorize all that, don't worry about it. You'll have a periodic table. As long as you know how to read the periodic table, you don't have to memorize any of this. So, again, that third energy level, remember, we can have as many sub-levels on an energy level as that energy level is. So if you're on the third energy level, you have 3 sub-levels, or can have up to 3 sub-levels. They are the 3s, the 3p, and the 3d. So orbital notation for scandium, that's the first element in 3d. We work our way through the first and second energy levels, fill up the 3s, fill up the 3p. We even open up the 4s. So we've gone to the fourth energy level, but then we come back to the 3d. Remember, there are 5 orbitals for the 3d. Kind of showed you in orange on the 2 slides ago. 5 potential orbitals, so we do have to draw all 5 of those blank lines. Scandium has just 1 electron in the 3d, so there he is, just 1 up arrow. Just like with the p, we would go up arrow, up arrow, up arrow, up arrow before partnering any of them up. An electron configuration, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, went 1 too far, there we go, 4s2, and then back to 3 for 3d1. Once we finish our entire row of 3d, and there's 10 elements there, we can hold 10 electrons in a d orbital. We move through that, and we go back to the 4p. Here's the 4p, so back up to the fourth energy level. We're back in P block. P block is this block of 6 here, 6 wide. And at that point, then you're done with the third energy level. You have filled it to its max. Third energy level can hold 18 electrons. You can put 2 in the 3s, 6 in the 3p, and 10 more in the 3d. So you put a total of 18 electrons into the third energy level. Continuing on from there, so 4p, after the 4p, again, we move down a row, time to get to the 5th energy level, and hopefully you're starting to recognize the pattern. The 5th energy level starts with the 5s. Here's our s block. Rubidium, strontium are 2 elements in the 5s. Then we go to the 4d. So it's kind of going backwards again. Always remember that this one here is the 3d. In fact, you take your periodic table and write 3d right next to scandium. That'll help. This is the 3d, which means the one after it, starting with y, iridium. That's our 4d. 4d. After 4d, we can continue back to 5. We go to the 5p. Here's the 5p. And after 5p, we open up the 6th energy level. 6th energy level starts with 6s. Again, hopefully as you're getting familiar or kind of comfortable with that pattern. When you're looking at that periodic table, it tells you right where you should be. So 5s to 4d, 4d to 5p, 5p to 6s. All right, we have another little bump in the road at 6s. See the block right here? Barium is 56. The one next to it is 71. That's not right. That's because we have F block. After 6s, we go back to the 4th energy level, from 6 back down to 4, and we open up our first F orbital. So similar to how the d orbital, 3d, was lower than the 4s in energy, so we had to go with the 4s first. In F block, even the 4f is a lot more energy than anything in the 5th energy level. So we wait until after we've opened up the 6s, and that's when we go to the 4f. And here is the 4f. F orbitals are nuts. They're like twice what a d orbital is, and I couldn't even draw a d orbital. We've got all these different lobes going in all these different directions. The one in the middle here is the double donut, super fun. And these are the f orbitals where electrons can exist. So once you get to an atom of this magnitude, man, those electrons are really going to some crazy looking places. And remember, once you get to that n equals 4 energy level, you can have 4 sublevels, 4 different orbitals. So 4s, 4p, 4d, and the 4f is the 4th sublevel. And the 4th energy level, we can hold a total of 32 electrons. So again, we put 2 electrons in the 4s, 6 more in the 4p, 10 in the 4d, and 14 electrons in the 4f. If you look at these different orbitals here, there are 7 different orbitals. So yes, that also means you have to draw 7 blank lines when you're doing orbital notation for an f orbital. So that's 14 electrons you put into an f orbital. That's 32 total electrons you can put onto the 4th energy level. By now, hopefully you guys have recognized that the periodic table is divided into blocks. And this is S block. It's only 2 wide because you can only put 2 electrons into an s orbital. On the far right, we have P block, and that's 6 wide because you can put 6 electrons into a p orbital. In the middle, we have D block, which is 10 wide because we can put 10 electrons into a D. And then down on the bottom, we have F block, which is 14 wide because we can put 14 electrons into F. So as long as you can kind of remember what block is where, you can always kind of tell where you're going with quantum mechanics. And the big things to watch out for is it's 3D after 4s and 4f after 6s. Now what a periodic table should look like, I don't know if you've had the chance to see mine here in the classroom, but what it should look like is this right here. Really, really long. That 4f kind of squeezes in there between 6s and 5d. And this is what it's supposed to look like, but it doesn't because it doesn't fit that way on a nice periodic table. Nice piece of paper, excuse me. So we can print it nice and easily when it looks like this, and so that's why we do it. And then you just have to keep in mind that when you get to number 56, 56 is followed by 57 down here, and not number 72. So watch your numberings, watch where those numbers are, and you'll be just fine remembering that 56 is followed by 57. All right, so let's finish this up now. After the 4f, we go to the 5d, and then the 6p. After the 6p, you open up the 7th energy level, and again, like all other energy levels, we're going to start that with the 7s. After the 7s, hey, following that pattern, we come back down to F block to the 5f. So 88 moves to 89. After 5f, we move back to the 6d, and then finally we wrap it up with the 7p, and that's it. That's all the electrons or all the atoms we currently have discovered. And actually any element that we add at this point will probably be man-made. In fact, many of the last ones are man-made and are not natural at all. So anything we add after this point would be man-made. And here's kind of a theoretical periodic table. Someday, somewhere out there, right now we're right here at 118. The next block we'd open up, for those of you who have recognized the pattern, would be 8s. 8s, 119. We'd open up 8th energy level, and that'd be 8s. After 8s, well, actually, we're going to add a 5G, a whole new block under the periodic table. And those of you guys recognizing patterns, we went from 2 to 6 to 10 to 14. This one would be 18 elements wide. So we're always adding 4. 2, 6, 10, 14. This one would be 18 elements wide. You'd have 9 different orbitals. But don't worry, you won't see that. It's all theoretical and in the future. This is as big as we get, and I don't even know if I'd ask you to do one that big. This is the orbital notation for OG, number 118, the last element on the periodic table. Lots of arrows. Lots of arrows.